In this lesson, you will be introduced to the principles and fundamental elements of dynamic HTML, DHTML. You will learn about document object models, DOM, and how style sheets and scripting languages interact with DOM to create DHTML. You will examine and create some simple DHTML applications and explore some more sophisticated illustrations. This lesson is not intended as comprehensive instruction in DHTML. It is only intended to acquaint you with some of the potential of DHTML. Dynamic HTML, DHTML, is a relatively new term when it comes to creating web pages and can have different meanings depending on who is using the term. The major browser companies, Microsoft and Netscape, have their own definitions, as does the World Wide Web Consortium. Note: World Wide Web Consortium is the international body that oversees the HTML standard. What the HTML boils down to is greater control for the HTML author over page elements. This results in new possibilities for page layout and in web pages which can change based on user action and input without having to access the server. This is different from regular HTML pages, which are basically static. You can click on a hyperlink, but that simply opens another page. Once the page is opened, it will not change. The DHTML instructions, just like the HTML tags, are part of the page. This is what allows the page to change without having to access the server. Instead, events in the browser are interpreted according to instructions contained in the page's source code. The page can actually rewrite itself and be reinterpreted by the browser for display, all without being reloaded from the server. DHTML allows you to set exactly where objects will appear in the browser window. Moreover, it will allow those objects to move in response to specific events or even be moved by the user. It will allow text or graphics on the page to be changed or even replaced completely, perhaps even by input from the user. And DHTML pages can become aware, remembering what a user has done or dynamically updating content from a data source. The application of these advantages requires imagination and some no small skill in scripting languages, but the result can be a much richer web environment than previously possible. DHTML works by defining objects on the page, then applying scripts to those objects that define how the objects will act. The identification of objects is known as Document Object Model, DOM. The scripts are created in scripting languages, such as JavaScript. The objects might be headings, an image, a paragraph, or any other page element as identified in the DOM. Because of this, style sheets are an integral component of DHTML. Styles of text objects can be set according to browser capabilities or user actions. For example, entire paragraphs may be caused to appear or disappear as a result of a mouse click. Thus, collapsible outlines or directory trees can be created. When DHTML-enabled browsers access a page, they catalog the tags on the page, and when the user interacts, example, passes the mouse over with an object, the script is invoked. There is a big difference, however, in how the two major browsers interpret DHTML. Netscape Navigator has a few of its own tags, such as layer, that allow individual or groups of HTML elements to become an object, but does not interpret many other HTML tags as being objects. Microsoft Internet Explorer is actually much closer to the HTML 4.0 standard, which does allow most HTML tags to become objects. For example, you might apply a script to an unordered list, UL, but because Netscape Navigator does not recognize UL as an object, the script is never invoked. Therefore, great care must be taken in using DHTML. you may have to provide alternative pages or risk having many users left out due to the version or brand of their browser. As stated earlier, this course has used the Internet Explorer 4.x browser from Microsoft because it more closely adheres to the standards for style sheets and DHTML. The discrepancy between IE 4.x and Navigator 4.x is particularly extreme in the case of DHTML. Many of the pages IE 4.x can display has to either be authored differently for Navigator 4.x or cannot be duplicated at all. Where possible, alternatives for Navigator are provided. But as no current browser interprets all of the new elements, IE 4.x has been used for this preview as it is closest to a full implementation. There are many good resources on the www to help you learn about DHTML and track the latest developments. Both Netscape and Microsoft provide reference materials and development examples at the URLs listed below. Throughout this lesson, you will learn of a variety of sites which will provide more information and demonstration of applications of DHTML. The concept behind the Document Object Model, DOM, is relatively simple. It defines the different paths of a document and describes the relationship between these paths. If it doesn't immediately seem clear that a document even has paths, it may help to think of it this way. A document is made up of paragraphs. Those paragraphs are made up of sentences. The sentences are made up of words. You could even carry it all the way out to the letters which make up the words. Each of these paths might be considered as objects in the document. In this example, the relationships are clear. The words are part of the sentence. The sentence could then be called the parent of the words, each one being a child of that sentence. The sentence is then a child of the paragraph which contains it. The various paragraphs are therefore the children of the parent document. Each child object belongs to some parent object. By its very nature, HTML identifies paths of a document. There is a head and a body. In the head may be a title. In the body may be headings, paragraphs, tables, forms, lists, and more. Not only does HTML identify these paths, but it also names them through the use of the HTML tags. Further, many of these HTML tags have attributes like the BG color attribute of the body tag. The background color can be thought of as a property of the body. In HTML, to create a red background for some document X, the naming structure looks like this: body BG color equals red. What a DOM does is create a way to address these objects and their properties. Under a DOM, the same objects and properties in document X might be written this way: document X.body.bgcolor equals red. In this example, object document X has a child body which has a property bgcolor which has been set to a value of red. Clearly, it seems that we could change the background color by setting this value to blue. But if HTML can already identify objects and set their properties, why create another system? Since such a system can be understood by scripting languages like JavaScript, we are now able to achieve new levels of intelligence and interactivity through the user's browser. Plain old HTML now becomes dynamic HTML. The DOM is therefore vital to the creation of dynamic HTML. The implementation of a DOM in a web browser actually first occurred in 1995 with Netscape Navigator 2.0 to support the introduction of LiveScript or JavaScript. Its only application at the time appeared to be the validation of form data. When a form was submitted, fields could be checked to see if they contained the right kind of data. This DOM identified the form as an object, as well as the child objects inside the form, such as the radio buttons or text fields. Work on the creation of style sheets in the HTML standard encouraged thinking about the different ways to identify and name elements in a document. You may remember that Netscape did not originally support the CSS standards. Therefore, two different DOMs emerged. The most obvious example is the use by Netscape of an object called layer to group objects together in a document, which is not recognized by HTML standards. Other browsers are using div, an accepted HTML element for this purpose. This and other differences in the DOMs mean that many pages will not be compatible with both major browsers. The good news is that Internet Explorer comes close to supporting the full supplement of HTML 4.0 elements. The same can be said for IE's support of JavaScript. It's also the only major browser at this writing to support any version of the newly proposed extensible markup language known as XML. Therefore, it is the preferred browser for DHTML. The bad news is that there are a lot of other browsers out there, so implementing DHTML is not practical in settings where you are trying to reach a broad audience. There is a brief but informative introduction to DOM at the web coder site. It is also a fine example of DHTML. DHTML syntax, the first step in creating DHTML applications, is to identify and name the objects to be included in a page. Of course, you probably will not identify every page element. You'll only specify those needed for your purposes. With HTML 4.0, there is now a new attribute, ID, for almost every tag. Through the ID attribute, you may give each individual HTML element a unique name, creating the objects used in DHTML applications. In the case of textual content, you may use the style and class names you used with the Cascading Style Sheets, CSS, to distinguish one block of text from another. Therefore, anything on a page can be identified and named. Here are a few examples. The first names a form field as T1. The second uses the ID attribute of the div tag to name a block of text as main text. The third uses the class name from a style definition to name a block of text as item. Once identified and named, you can perform operations on these objects, replacing them, moving them, or setting their properties. This requires the use of the hierarchy of objects as described in the Document Object Model, DOM. In response to a user moving a cursor over a word, you might set the color of a named block of text to red. But in order to do more than simply react to events in the browser, the scripting languages like JavaScript become vital. Now you have the ability to evaluate the user's input and respond accordingly. These are the building blocks of some very complex web-based applications. Creating and using DHTML. There are three building blocks of DHTML: style sheets, scripting languages, and the DOM as implemented by the browser. What you can create depends on your skill and imagination. The only real limit is the implementation of these three components by the browser. Unfortunately, those limitations are still severe. The following exercises will demonstrate solutions based on CSSI plus JavaScript and the DOM of the Internet Explorer 4.x browser. You will build some simple applications and examine some more complex examples. You will also get to examine some applications as implemented in alternative versions of Navigator 4.x and Internet Explorer 4.x browsers. As you will see, DHTML is certainly worthy of a course of its own, but you should get a glimpse of the possibilities. This application has three parts. The part you created establishes the target or placeholder for the text the user will type. It uses the div tag to create a named object of the document through the ID attribute. This object will now be recognized by the browser by the name replace me. The second part of the application creates an object for user input. In this case, the input tag is used outside of its usual function as part of a form. The type is set to provide a text field, and the size of that file is set with a style attribute. Most importantly, this field is named T1, again using the ID attribute. Finally, the action of the application is provided through the use of another form input, in this case a button. The button is augmented with a little JavaScript statement to handle the user event, a mouse click. Using a property called innerHTML, all the content between the HTML tags of the div object called replaceMe will be replaced with the value of the object called T1 when the button is clicked. In this case, the value of that object is the text the user typed. The equation is read as object.property equal to value, or in plain English, the property of this object should be set to this value. Though this is obviously not a very useful application, it does illustrate your ability to create objects, respond to user actions, and change page elements by setting the properties of these objects. Here is how it is viewed in the web browser. This application is quite easy. It uses style definitions, a naming syntax from the DOM, and another piece of JavaScript to handle the user action. The style definitions are ordinary CSS and define two classes, on and off. This format is used only so that you can see the elements used more easily. The second part of the application applies the styles to an object, in this case a hyperlink. By default, when the document is loaded, the class name is off. The effect is triggered by the cursor over the hyperlink, changing the style as the cursor moves on and off the hyperlink by resetting the class name of the style. This is the generic name for an object holding the focus of the current event, in this case, the hyperlink which the cursor is moving over. Class name represents a property of the object which is then set to on or off. Note the semicolon after on and off. This punctuation is important as the end of a statement in JavaScript. Here is another example of using a change of styles as a way of animating text. In this case, the text is again changed by resetting the class name. In addition, the scripting handles a little graphic animation created by the swapping of GIF files. Here is how it is viewed on the web browser. Having created applications which are capable of responding to user actions, you can go further by adding some logic to your scripts. This will enable you to evaluate user actions and more specific responses. Again, you will use the DOM to identify objects to be manipulated based on instructions from the script. Here is one simple example of JavaScript. This application shows a simple branching function. First, the answer choices are created and named as objects. In this case, the table cells become the objects with a unique name, direct or digital. If there is a mouse click inside the cell, a function which will be defined in the script is activated. An extra guide for the user has been provided by setting the cursor through a style definition for the cells. Next, an object to contain the feedback is created by creating and naming an img. Through the function that is created when the user makes a choice, the browser checks for the ID of that object. Depending on that ID, the question mark graphic is replaced with one providing feedback to the user by resetting the source of the response object. First, a variable is declared, then given a value. This is a standard way of creating author-defined elements in programming and scripting. In this case, its only purpose is to shorten and to simplify the naming of objects. Now the function checks the ID of the object. If it is direct, then it instructs the browser to use the wrong .gif as the source of the response object. Otherwise, the browser is to use the right .gif. If you choose the wrong answer, the result would be like this. And if you were lucky enough to choose the right answer, then the result would be like this. Note that if you had more answer choices, you could set the function to check for each specific possibility. Also, you could replace a block of text as shown in an earlier exercise. Or you could send the user to another page or multimedia file in response by replacing the response.scr equal to statement with something like the following. Clearly, you are now able to create intelligent applications that do not rely on server-side processing. Of course, they will rely on your knowledge of a scripting language like JavaScript. The next example shows a slightly more complex application of the same scripting logic. The outline items are contained in div, which are displayed or hidden based on their current style value. The first step is to organize the content, create the connection between the content and the icons the user will click to animate the outline. Let's work up the outline from the deepest section to the top. This div tag encloses the deepest level of the outline, item 1.1.1 and item 1.1.2. The ID assigned is out2D and the style is set to display none. Obviously, when the page loads, you will not see this section of the outline. The item 1.2 level of the outline is created with the source text highlighted. Another div tag is used and given a name out1d. Again, because of the assigned style, this section of the outline will not be seen when the document is loaded. In addition, an img tag is created that contains the folder icon that designates a collapsible section of the outline. The img tag has an ID of out2, which is intended to correspond with the name of the first div tag, which was out2d. Again, because of the assigned style, this section of the outline will not be seen when the document is loaded. Further, the img has been assigned a class name. Though this class is not identified as a style, as in previous examples, it is simply another way of naming the object. Finally, a style is assigned to create a cursor to prompt the user that this is a clickable location. Now the last, top level of the outline with item 1 is added. The naming convention for the objects is the same as before. The img before a div has a corresponding name, so each section of the outline has a name and a named icon associated with it. Now you move to the script. First, you name the function, then declare some variables and assign a value to one of them. As before, these variables are principally for convenience in naming objects. The click handler function is designed to evaluate a mouse click by the user. At the bottom of the script, it is assigned to handle any click anywhere in the document. Next, the function evaluates the object that has been clicked. If its class name is outline, then a value is set for the target ID variable. What is it the user has been prompted to click? The folder icons all have a class name of outline, and their ID is out plus a number. This ID is the scr element.id mentioned in the script. If you take this ID, out1 for example, and add the letter D to it, you now have the ID of a corresponding div section, namely out1d in this instance. Now the last variable, target element, can be set. Here the target element is any instance of an object with the ID of out1d. Now the logic of the script can get to work. If the display property of the object is set to none, then the display is reset to the display which in IE 4.x is the default. In addition to the named div section becoming visible, the source of the original source element, the folder icon, is now set to a new folder icon to indicate the open section of folder.gif. In the event that the element is already displayed, the script sets the value back to none and changes the icon back to the original folder. The work of the script is finished. You can create an outline with as many sections as you wish without any more scripting, merely by creating this naming convention for the clickable objects and the corresponding text objects. This solution for collapsible outlines only works in Internet Explorer 4.x. However, when viewed in other browsers, the entire list should be visible. The collapsing action does not occur, but users should see all of the content.